Hi everybody, this is Shiva Biram signing in. In this session, I am going to introduce a new topic regarding electrical utilization. As a first part of it, I am going to explain you the basics of illumination. In this session, we are going to have the topics related to plane angle, solid angle, luminous intensity, illumination, and also the laws of illumination. These are fundamental definitions that we should know before going to understand the laws of illumination. Plane angle, everybody knows that it is the angle subtended by two converging straight lines at a particular point. It is represented by the Greek letter theta and is measured in either degrees or radians. In the same way, solid angle is related to three-dimensional. It is the angle subtended by an infinite number of lines in a volume of space coming from an area. So here we are going to consider an area, and these are the lines, number of lines coming from this area meeting at this particular point, and whatever angle is enclosed by this infinite number of lines at this point is considered as a solid angle. And the formula for finding out is represented by the letter omega, and the formula for finding out the solid angle is area divided by radius square. Area means whatever area we are going to consider, that is the area, and radius means from the center point, from the this point, whatever distance is there, radial distance is there, that is considered as the radius, and it is measured in steradians represented by SD. And there is a formula which is going to relate the plane angle and solid angle, which is given as omega is equal to 2 pi into 1 minus cos theta by 2. If you consider a sphere, the maximum solid angle subtended at its center is 4 pi, because the area of a sphere is 4 pi r square divided by r square. So r square gets cancelled each other, and we will be left over with the 4 pi. It is the maximum angle subtended by a sphere at its center. Next, let us go through the definitions of luminous intensity here. Both are same, luminous intensity or Cp of Cp means candle power of a source. It is represented by I or Cp. It is the luminous flux emitted in a solid angle per unit solid angle in a particular direction. So if you consider the luminous intensity or candle power of a source, it is represented in lumens per steradians or candela or CD. Means the flux per unit solid angle in a given direction is considered as luminous intensity. As simple as that. Similarly, illumination, it is represented by E. This particular definition relates to a surface which is going to kept under light. How much flux is being received by the surface per its area, that is considered as illumination. Hence it is equal to the luminous flux divided by the area, which is measured in lumens per square meter or lux. These fundamental definitions are very much essential in order to understand the laws of illumination. Next, basically we are going to have two laws of illumination. Inverse square law is the first one, and Lambert's cosine law is the second one. So inverse square law, actually it states that the illumination of a surface is inversely proportional to square of the distance between the source and the area which is to be illuminated. That means illumination will be inversely proportional to square of the distance. So let me explain you with an example here. I am going to consider a point source of light here and three different areas having the areas of A1, A2 and A3. Let us assume that the luminous intensity of the source is same, I. So A1 is the first area, A2 is the second one, and A3 is the third one, which are kept at a distances of D1, D2 and D3 respectively from the source of light. So that is the source we are considering here. And if you find out the flux received by all these three surfaces, first let us find out the flux received by the flux received by A1, which is equal to the luminous intensity multiplied by the solid angle of A1. So the luminous intensity is considered as I here, so which is I multiplied by the solid angle is omega. I into omega is A1 by D1 square, so that we have considered previously. Similarly, if flux is this much, we can find out the illumination as flux by area. Illumination E1 is equal to flux divided by the area A1. So A1 gets cancelled each other. We will be left over with I by D1 square. So we are going to have I by D1 square lux. Similarly, you can find out the illumination of the surfaces A2 and A3. And we get here E2 as equal to I by D2 square and E3 as equal to I by D3 square. And if you compare these three things, E1, E2 and E3, we are going to have E1 colon E2 colon E3 is equal to 1 by D1 square plus 1 by D1 square is 1 by D2 square is 1 by D3 square. So this is about the first law of illumination. From this we can say that the illumination is inversely proportional to square of the distance. Second one is Lambert's cosine law. Here we are going to consider the surface to be illuminated is not exactly below the source, but it is kept at a distance from the ground. Here the source is being considered at height of h from the ground here. And now the objective is to find out the illumination of the surface which is kept along this axis or along this horizontal. So here I am going to consider CD as the surface which is to be illuminated, and let us find out it is the perpendicular component of CD with respect to the light rays. So this is normal to CD, normal to the surface. So wherever we need to find out the illumination, there we consider this normal. So this area, this dotted line which is represented here, this is the area perpendicular to the source of light. So I am going to consider this dotted line as AB. It is the surface area which is perpendicular to the direction of light. Let us say that distance is D. AB is considered as the surface, 90 degrees, and if this angle is theta, obviously this will be 90 minus theta and this angle will be equal to theta, and AB is equal to CD cos theta. So if you find out cos theta here, you will be getting AB by CD. From that you get AB is equal to CD cos theta. So if this angle is theta, this will be theta, and also this angle also will be equal to theta. So let me explain once again. If you consider this angle as theta, as it is 90 degrees, this will be 90 minus theta, and again this is another 90 degrees. If it is 90 minus theta, this will be equal to theta, and once this angle is theta, this will be equal to theta, because these two are alternate angles. Hope this is clear to you. And if you find out the illumination of surface AB, okay, this is perpendicular to the light rays or the source. Now let us find out the illumination of this surface AB here, which is equal to flux by area of AB, or you can also consider it as I by d square, or equal to flux by area of AB. And similarly, illumination of CD is equal to flux divided by area of CD. So whatever flux is being received by the surface CD divided by the area. So here I by d square also is equal to flux divided by the area of AB, and we know that the area of CD is given as AB by cos theta. CD is given as so flux by area multiplied by cosine cos theta here. That implies I by d square, because this flux by area is equal to I by d square multiplied by cos theta. So here theta is the angle between the normal to the surface and the direction of light. So from this right angle triangle, if you consider cos theta is equal to h by d, so if you substitute here d is equal to h by cos theta, that is d square means h square by cos square theta into cos theta, we get here I by h square into cos cube theta. Hence it is also considered as a cubic cosine law. Lambert's cosine law is also considered as cubic cosine law. Okay, that's all for today's session. In the next session, I am going to give you some more information regarding this illumination, and also a problems related to, we are going to solve the problems related to the loss of illumination, and how to design lighting schemes for a given hall or drawing hall or some workshops like that. So keep watching my videos, subscribe to my channel, and give your valuable feedback. Thank you very much, and this is the Shiva Biram signing off.